Good day, BSN 1A students. We are the Group 5 and we are going to tackle about the computer codes, specifically its errors and correction. So I'm Clarissa Salmiento, the group leader, and my members are Farhana Masakal, Joanna Marie, Jolex Conato, Lady Rica Ocampo, and Carly Shanalin Upao. So I hope that you spare time to listen and learn something from our discussion. The world is complicated and imperfect place, and errors can occur whenever information is stored or transmitted. Data stored on hard disks, DVDs, and flash memory, and it can be changed if there's a tiny fault in a device, and these occur regularly. You might also wondering how DVDs can still play movies even though it has scratches on them. So the answer to this problem will be tackled on our next slides. So I'll be leaving the floor to Miss Joanna to discuss the definition of errors.
Oops, dali lang. So before we proceed with Miss Joanna, I wanted to read this to all of you to inspire and motivate you throughout the discussion. So by the way, I'm Farhana Masakal and I'm going to be your entertainer for today. Just kidding. So this is a quote from someone famous from a book entitled Di Mo Sure, page Walang Katapusan. So this is a quote, words full of wisdom that someone important said and can make the reader get inspired, and that's the quote of the day. So I hope you listen and stay focused. So Miss Joanna, you can proceed with your topic.
What is error? Error is a condition when the output information does not match with the input information. During transmission, digital signals suffer from noise that can introduce errors in the binary bits traveling from one system to another. That means a 0 bit may change to 1 or a 1 bit may change to 0.
When data is being transmitted from one machine to another, it may be possible that data become corrupted on its way. Some of the bits may be altered, damaged, or lost during transmission. Such as condition is known as an error. The error may occur because of noise online, attenuation, and delay distortion. For reliable communication, it is important that errors are detected and corrected. There are two main types of errors in transmission. First is the bit error. It means only one bit of data unit is changed from 1 to 0 or from 0 to 1 as shown in the figure. Single bit error can happen in parallel transmission where all the data bits are transmitted using separate wires. Single bit errors are the least likely type of errors in serial transmission. Burst error. In burst error, two or more bits in the data unit have changed. It means two or more bits in a data unit are changed from 1 to 0, from 0 to 1 as shown in the figure. In burst error, it is not necessary that only consecutive bits are changed. The length of burst error is measured from first changed bit to last changed bit as shown in the figure. Length of burst error is 8, although some bits are unchanged between. Burst error is most likely to occur in a serial transmission. The noise occurring for a longer duration affects multiple bits. The number of bits affected depends on the data rate and duration of noise.
Error detecting and correcting codes. Computers can make errors when they are transmitting data. Most errors are caused by electrostatic or magnetic related environmental conditions. Most of the errors are single bit errors. They are error detecting codes such as parity or check bits and error correction codes such as Hamming codes. Okay, so let's proceed the error detecting codes. Information received over the networks can be corrupted if there are interference on the line or faulty components in the system. Scanning information from a barcode and QR code is a form of information transmission, and a small error such as dirt or scratches on the code can change the information. Yet we rely on the data so much that there could be a serious implication from even a single-digit error in a student's grade. a small change to a payment, or an incorrect reading in the medical scan. Error detection techniques adds extra information to data to determine when errors have occurred. Error detecting codes are a sequence of numbers generated by specific procedures for detecting errors in data that has been transmitted over the computer networks. When bits are transmitted over the computer networks, they are subject to get corrupted due to interference and network problems. The corrupted bits leads to spurious data being received by the receiver, and they are called errors. Error detecting codes is being used to avoid transmitted messages to get scrambled or corrupted by the noise or data. These are additional data added to a given digital message to help us detect if an error occurred during the transmission of the messages. A simple example of error detecting codes is a parity check. The basic error detecting mechanism is by use of parity bits or check bits. It can detect single bit errors. There are two types of parity, the odd parity and even parity, to be discussed in the next slide.
Parity is an extra bit that is sent with the message signal. So it detects signal bit error. Also, parity is a way of trying to establish if binary data has changed during transmission. So there are two types of the parity, the even parity and the odd parity. So when we say even parity, so the number of ones in a given word, including the parity bit, is even. And when you say even, so those are the numbers 2, 4, 6, 8, and so on. On the other hand, the odd parity, here the number of the ones in the given word, including the parity bit, is odd. So the example of the odd numbers are 1, 3, 5, 7, 11, 13, and so on. So now let's know how does parity checking work. So first of all, communicating computer needs to decide upon which protocol to be used. Then they will decide either even or odd parity protocol they will use. And then after that, each bit is going to be sent. Then one bit becomes a parity bit. A parity bit will be either 0 or 1, but that depends upon which protocol chosen by the two computers communicating. If they agree to use even parity rule, then parity bit needs to be set to 1 of a 0 to ensure that it was an even number ones in a byte and even number zeros in a byte. If a two computer have decided to use an odd protocol, then the parity bit should have to establish an odd number ones and a zero number in the byte. So also we can see a word data bit. So it is a number of a bit used to represent one character of data. Also, data bit is the smallest unit of data in a computer. A bit has a single binary value. It is also either 0 or 1. All the computer usually provide instructions that can test and manipulate bit. They generally are designed to store data and execute instructions in a bit multiples called bytes. Error detecting code, parity bit. A single bit called parity bit is added to given set of numbers based on the count of the number of ones in the given set of bits. So here we can see in the case of the even parity, so if the count is odd, the parity bit value is set to 1. So making the total count of occurrences of ones in a given set of bit is already even. So the parity bit value is 0. And also we can see in the case of the add party, so if the count is even, so the parity bit value is set to 1, making the total count of the accuracy of ones in a whole set. So this includes the parity bit and odd number. So if the count of a ones in a given set of bit is already odd, then the parity bit value is 0.
So we have here another illustration. We have here the data on the left side, the 10100010101. So that is our original message from the sender, and it will proceed to the generating function. And upon the transmission, there will be an additional of the parity check or the redundancy check, the 101101. So we already have here the data and the redundancy check, and it will be transmitted to the receiver. So at the receiver, we have here the checking function, and it will going to use the parity check in order to scan the data check in order to scan the data. And if there is no error at all, then the receiver will accept it. And if there is an error detected, then the checking function will reject it. So that is how the error detection and error correction works.
We can also pass some data to figure out the original message from the corrupt message that we receive. Error correcting codes are deployed the same strategy as error detecting codes, but additionally, such as codes also detected the exact location of the corrupt bit. In error correcting codes, parity check is a simple way to detect errors along with a simple, sophisticated mechanism to determine the corrupt location. Once the corrupt bit is located, its value is reverted from 0 to 1 or 1 to 0 to get the original message. Some code words detected and automatically correct the codes, such as codes are known as error correcting codes. For example, we might have a string of bits 0, 1, 1, 0, 1. An error in the fourth bit would cause 0 to become a 1, resulting in the new message 0111. Our goal with error correcting code is to locate these errors and correct them.
Okay, so now let's proceed on how are we going to detect and correct errors. Since we already identified the definition of the errors, which means that the output information does not match with the input information. So which means that the original message is not being received as it is. There is an alteration in the data. Just like for example, when the sender sent 101 and the receiver received 111, then there is already an error with it. So, in order for us to detect or to identify the errors in a certain data, and how are we going to correct that? We have this called additional bits. This is being added to the data bits or the original message of the sender at the same time of transmission. So, this means that right after the sender sent the data, there is a process along the transmission, which means there is a process already of the additional bits. So when the sender sent the data, there will be an additional bits right away along the transmission before it is being received by the receiver. So these additional bits are called the parity bits. So please remember that. So this is are called parity bits, or this is an extra bit that is sent with the message signal, and it detects single bit error. So to further understand this, just like for example, when the sender when the sender sent data of 1101101 and it is being sent, and along with the transmission phase, there will be an additional bits, just like what I've said. So we already have this data bits or the original message from the sender, and the additional bits or the parity bits. So we already have two sets of data, the parity bits and the data bits. So this data will then be received by the receiver. And at the receiver, there will be a checking function. So this checking function will use these parity bits in order to detect any errors in the data bits or the original data from the sender. So this means that these parity bits serve as the basis in order to identify error in the data bit. So I hope we are clear with that. So the data bits along with the parity bits form a code word. So those two data or the data bits or the original message added by the additional bits or the parity bits. So these two will form a code word. So this code word is typically used for reasons of reliability, clarity, or secrecy. Each code word is assembled in accordance with specific rules of the code and assigned a unique meaning. So we have here the parity checking of error detection. It is the simplest technique for detecting and correcting errors. So we have here the image, the MSB, this is the most significant bit, and the LSB, this is the least significant bit. And we have here the P, which stands for the parity bit, and the 7 data bits, which are the D6, D5, D4, D3, D2, D1, and D0. So we have here the 7 bits. These are the remaining bits of an 8 bits word and are used as data or message bits. So the overall data in the image, as you can see, that is called the 8 bits word because we have here the 7 data bits and 1 parity bit. So but this 7 data bits, this is the original message from the receiver. So just like what I've said earlier. So the parity of 8 bits transmitted word can be either even bit or odd parity. So the parity bit, it can be either odd or even. So the even are the 2, 4, 6, like that, and the odd are the 3, 5, 7, like that. So the MSB, this is the most significant bit, or the bit furthest to the left, used as the parity bit. So we have here another image. So we're going to determine if the parity bit is odd or even. So we have here on the left upper portion, the parity bit is 0, and we have the 7 data bits, the 1, 0, 0, 1, 0, 1, 1. So since our parity bit is 0, we're going to count a number of 0 in the 7 data bits. So we have here 1, 2, 3. So we have 3 zeros in 7 data bits. So which means this is odd parity. So let's proceed to the left or to the right upper portion. So the parity bit is 1. So we're going to determine the number of ones in the data bits. So we have here 1, 2, 3, 4. So we have 4 ones in the data bits. So it means that is even parity. So let's proceed to the left lower portion. The parity bit is 1. Okay, so we're going to determine number of ones in the data bits. So we have here 1, 2, 3, and 4. So still it is even parity. So on the left side, we have here 0 parity bit, and we're going to determine number of 0 in the data bits. So we have here 1, 2, 3, and 4. So which means this right lower portion data bits has a even parity. So I hope you understand how it works.
How does error detection take place? Parity checking at the receiver can detect the presence of an error if the parity of the receiver signal is different from the expected parity. That means if it is known that the parity of the transmitted signal is always going to be even, and if the received signal has an odd parity, then the receiver can conclude that the received signal is not correct.
Repetition code. So we have here the example of a repetition code. So if you had a message 01101, so we could encode it using the repetition method, and it would become 0001111000111. So as we can observe the original message, so the nag-repeat lang tayo na 3 times. Okay, so now we have here the message. So another message, we have 100, 111, 101, 000, 110, which includes multiple errors. So jakara, we're going to determine kung ano ang nga original message. So here we're going to observe sa message nga to kung ano nga number ang nag-repeat in order for us to know what is the original nga message. So, sa example nga una, so bali na nag-repeat lang man tana, di ba? So, sa aton ng tawon kung ano nga number ang mas raka nga nag-repeat. So, here, so we're going to look at the message. So, first we have 100. So, here, lahat natin kung ano nga number ang nag-repeat. So, we can see naman na ang 0 ang nag-repeat. So, sa una, ang mura ang original nga number. So, next, we have 111. So, since may repetition yung natabo, so there is no error. So, ang original nga number is 1. Next is 101. So, nag-repeat nga number is 1. So, ang anang original nga message is 1. Next is 000. Then, may repetition tana. So, ang anang original message is 0. Next is 110. So, ang number nga nag-repeat is 1. Then, so, as we punta pa natin, so we have the original number, which is 01101. So, ang murang original nga message. So, that's the most classical example of error correction. So, for each bit in an input message, so we duplicate each bit multiple times. So, it is important to note that if more than one bit in this 3 bit segment was affected by an error, so we could no longer correct the error.
So there you have it, and again, I'm finally back and we've come to an end. By the way, thank you dear reporters for that very informative discussion. And by ending our presentation, I'm going to read the last part wherein the lessons in this unit shows how errors can be detected and in same cases corrected to restore the original data. It also enables students to explore how we use some relatively simple ideas to make our digital systems so reliable that people using them don't even realize that this is all happening underneath the surface. And that's it for our topic today, and I hope you learned something. So thank you so much for listening. Have a great day ahead.